Hello, welcome. We're here today talking about the Pythagorean Theorem. And so I guess the first thing to make mention here for Pythagorean Theorem is that this will only work, so only applies to right triangles. So a right triangle is a triangle that has a 90-degree angle in there, okay? And so we typically show 90 degrees with this box here. So this is telling us that that's a 90-degree angle. Okay, so a triangle can only have one 90 degree, and the other two would be less than 90 and add up, in fact, to 90, because the three angles within a triangle add up to 180. So if this is 90, then these two together make 90. Okay, so Pythagorean theorem, before we even get into it, will only apply to right triangles. Okay, so first thing, we need to name parts of this triangle. Okay, so the most important part or the most important side of a right triangle is the longest side. Okay, and it happens to be the side across from the 90-degree angle. So if you have your 90 here, if you go, I almost think of this corner as an arrow, okay, pointing towards the longest side. So going across that triangle, this is the longest side. We call the longest side the hypotenuse. Okay, so that's the longest side, and it's always across from the 90. Okay, so that's the hypotenuse. Now the other two sides, okay, they're always going to be shorter than the hypotenuse, and for the purpose of Pythagorean theorem, they are pretty much interchangeable. So we actually just call them legs. So it doesn't matter which one is which. This is, let's say, leg 1, and this is leg 2. Okay, or this could have been leg 1 and this could have been leg 2. It really doesn't matter. These two will be interchangeable when working with Pythagorean theorem. The important one is the hypotenuse. Okay, as long as you recognize the longest side that's across from the 90, then the rest will be easy. Okay, so what is the Pythagorean theorem? So Pythagorean theorem essentially says that if you square these smaller sides and add them up, it will always equal the square of this longer side. So how do we say that? So Pythagorean theorem, and so now this is how I will always say this. Okay, the hypotenuse, this long side, this important side, will always be by itself. So I'm sorry, I'm calling this C. We normally call the legs A and B. Doesn't matter which one is A and which one is B. And the hypotenuse we usually call side C. Okay, in terms of, or for use of this formula, A, B, and C. So it tells you that the hypotenuse squared, so C squared, will always be the sum of the legs squared. So the sum of the legs, sum is when you add them up. So if you said A squared plus B squared. So if you square one side, one leg, and you square the other leg, when you add them up, you'll always get the square of the hypotenuse. Okay, so instead of using C squared, A squared, B squared, we could have also written this as the hypotenuse. Let's go red. The hypotenuse squared is equal to leg 1 squared plus leg 2 squared. Okay, so the important thing here is that the hypotenuse is on its own, okay, and the legs go together on the other side. Okay, so let's see how this works here. So with this first example, okay, we're asked to find x, so we're solving for x here. Okay, so the first thing you need to do with Pythagorean theorem questions is to identify the hypotenuse. Okay, so, and I guess I should mention Pythagorean theorem, you can use it as long as there's a 90 degree, and as long as you have two of the sides, you can find the third side. Okay, if you don't have two of the sides, you won't be able to find the third side with Pythagorean theorem. Okay, that'll take you into trigonometry with using sine and cosine and things like that. So we have two sides of a right triangle. We can find the third using Pythagorean theorem. So let's identify these sides. So if my 90 is here, right, remember that arrow across from the 90 is the hypotenuse. So this is my hypotenuse here. Okay, the other two sides, it doesn't matter which one is which. One is leg 1 and the other is leg 2. Okay, and so if we use this formula here, Pythagorean theorem says the hypotenuse squared will be by itself on one side. So in this case, the hypotenuse is x. So in place of hypotenuse, I'm going to write the letter x. So it's going to be x squared, okay, is going to equal leg 1 squared. Well, what's leg 1? We called it 3. We called this side leg 1. So that's going to be 3 squared. That's leg 1 plus leg 2 squared. Leg 2 is 4 feet. So 4 squared. Okay, so hypotenuse squared is equal to leg 1 squared plus leg 2 squared. Okay, once you have it set up like that, it really is just solving equations using order of operations and opposite operations. Okay, so we're going to leave x squared alone right now. We're going to clean up this right side. So 3 squared is 9, 3 times 3, plus 4 squared, so that's 4 times 4, that's 16. Okay, and so now we're at the point where we say x squared is equal to 9 plus 16 is 25. Okay, x squared is equal to 25. So think about what this means. X squared is saying this side multiplied by itself is going to equal 25. So something times itself is equal to 25. Okay, so if you think 3 times 3 is 9, 4 times 4 is 16, it's actually 5 times 5 would give you 25. So x must be 5. Now how do we do this if it's a number we don't know? Okay, so we use the opposite operation. So the opposite of squaring the x is square root. Square root is the opposite of squaring. And by doing the opposite, you cancel those operations out and you're left with just the x. Okay, so if you squared something and square root it, it essentially takes you back to that original value. Okay, and do the same on the right side. Right, whatever you do to one side of an equation, you do to the other to keep the balance. And so square root of 25, you can go to your calculator, but you would find that it tells you 5 times 5 is 25. So the square root of 25 is 5. And now let's not forget the units. Since this triangle had units given in feet, the side lengths were in feet, this hypotenuse then must be in feet. Okay, so there you go. X is 5 feet. Now this is a very common right triangle, 3, 4, 5. Okay, it doesn't always work that way. It's not necessarily going to be adding 1 every time. So it won't be, 4, 5, 6 and 6, 7, 8. This is a special one. Okay, so 3, 4, 5 is a very common special one. It gets used by contractors and architects and designers because it basically defines a triangle with a right angle. Okay, so this is a good one to know, the 3, 4, 5. Okay, so let's go ahead and do the next one. And I should mention too, these are really the only two types of questions you can get with Pythagorean theorem. One in which you're looking for the hypotenuse, okay, and one in which you are given the hypotenuse. So in this case, there's my 90, there's my arrow pointing to the opposite side of the 90. So this is the hypotenuse. So in this case, I'm given the hypotenuse, the value. Okay, so I'm going to be finding a shorter side. I guess we didn't label this. Let's call this x over here. Okay, so I'm going to be finding a smaller side. Okay, so let's label everything again. So there's a hypotenuse, 13, and these are my legs. Leg 1 and leg 2 doesn't matter. Let's call this one leg 1 and this one leg 2. It really doesn't matter though. So following our formula up here, it says take the hypotenuse squared and put that on one side by itself. So in this case, the hypotenuse is 13, so I'm going to put that on one side by itself, and I have to square it. Okay, and on the right side I put the legs, and again the order doesn't matter. I called this one leg 1, so let's write that one first. So it's leg 1 squared, so x is my leg 1, so it's going to be x squared plus leg 2 squared. Leg 2 is 5, so plus 5 squared. Now keep in mind, we always need to square when we're using Pythagorean theorem, okay? Now let's go to our calculator and clean some of this up. Okay, so 13 squared is 169. Okay, and that's going to equal x squared plus 5 squared is 25. 5 times 5. Okay, now when we're solving for x here, we want to get this by itself. So think back to solving equations. Okay, we're going to perform opposite operations here. So what's the opposite of adding 25? We want to get rid of this 25, so the x squared is by itself. So the opposite of adding 25 is to subtract 25. Okay, but if you do it to one side, you must do it to the other side. Okay, and so it cancels out here. It gives you 0. So you're just left with that x squared. Okay, so on this side you're just left with x squared. And on this side here, 169 minus 25 is 144. Okay. Now we get to a point where it looks similar to this. X squared equals a number, x squared equals a number. And so the opposite of squaring is square root. So again, you'll square root on this side and do the same on the other side. And by doing that, okay, square rooting a squared term just brings you to the x, gives you the original value. Okay, so the squaring and square root cancel each other out. And on this side, square rooting 144, so that's, again, you can go to your calculator, but that will tell you it's 12, and again we used feet, so 12 feet. Okay, so this is another common triangle, 5, 12, 13. Okay, so just to recap really quickly here, if you're looking for the hypotenuse, that's the longest side, you will be adding values. Your number is going to be bigger than those other two, so bigger means you will add. Okay, so 3 squared plus 4 squared will give you x squared. Okay, and you can square root at the end there. If you're looking for a side that's smaller, because you are given the hypotenuse and this has to be the longest side, so knowing that you're going to get a smaller side, somewhere along the way you subtract, okay, because this will end up making things smaller. So essentially it's going to be 13 squared minus 5 squared. Okay, so here I added 3 squared and 4 squared because I'm trying to get a bigger number. In this case, a smaller number, so I would subtract 13 squared, subtract 5 squared. Okay, and in the end, for both, the last step is to square root, and that'll give you your side length. Okay, and just check the reasonableness of your solution too. Okay, normally, you know, diagrams might not be drawn to a perfect scale, but close enough where you can see that it makes sense. Okay, so if this is 5, it makes sense that that could be 12. Okay, because it's a lot closer to the length of 13 than it is to the length of 5. Okay, so that's Pythagorean theorem. I hope that helps, and good luck.